Let's consider a simply supported beam. Start with very simple. So simply supported beam, say only maybe or maybe at the center. Okay, you start with center loading. Say this is 20 keep, and this value say 10 feet, and this value say 10 feet. Make it very simple at the beginning. It is a simply supported beam with center concentrated loading. What we will do, we will determine or draw the normal force diagram, shear force diagram, and moment diagram. So what is step number one? Step number one, now it is in your handout also, but I am not reading your handout because you can read it. The concept is same. For mathematics, we need to know the concept. Yeah. And it is mathematics type. Uh, Knowledge is very small, more practice. Okay, step number one. Step number one. What is this? Step number one is to find all reaction. So you need to find all reaction in this beam. All means, oh, I didn't write all. All means all reaction. Step number two depends on the diagram. Say for shear. If I want to discuss the normal force diagram. Normal force, if it is tension positive, tension means positive, we learned that. Compression means negative. Shear force, we will discuss shear force. What are the steps for shear force? Shear force is step number two for shear force. Step number two for shear force is, okay, right, for shear force, follow loads. Follow loads. We will follow loads to draw shear force diagram. Okay, for moment, what are the steps? Step is obviously step number one, draw the find all the reaction and draw the shear force diagram. Then number three, step number three will be sum up shear force. And I wrote here very short. Yes, you can read your handout to read the entire sentence. The simple step is, for step number one, find all the reaction. Done. Step number two, for shear force, follow the loads. For moment, step number three, sum up the shear force. That is. Now we will do on the one example. Say this example. Now first find all the reaction. Okay, so then what to do? Draw a free body diagram. So here I have one unknown is AY, another unknown here is AX, one unknown here is BY. Okay, so if I take summation of Fx is 0, there is no force along x direction, so Ax is 0. One reaction done. Simple. Anybody can find it without doing any calculation. Now in your beam, in your exam, if you can tell the answer without solving, it is good. But at the same time, in university or classes, we want to see your work. That how did you find it? Did you copy from your neighbor or you solved it? Yes. So always try to show your work, that what you did. We did this and found this. Okay, now if I apply summation of moment, say at A is 0, then clockwise moment say positive, then A means here my fast force is 20 keep, distance is 10 feet, and it is positive because clockwise. Next force is by will give me counterclockwise moment because it is that way with respect to point A. Now distance 10 feet 20. Now if I solve it, I will get by is 10 keep. Now how I found it, by 10 keep without any calculation? Because I wrote the equation, and also if you are smart, it is symmetric beam, load at the middle, so 50-50, you know the answer, but you have to show the work how you found it. Or if you write the beam is symmetric, load is at the middle, So 50% will go to left support, 50% will go to right support. If you write it down, then still though your examiner or instructor will understand that you know it. That is also okay, yes. So you have to show your work where you found it. Do not write that I got it from my neighbor. It's not a good answer. So we found by. What is ay? Now I apply summation of fy. Summation of fy is 0. Say upward is for positive. So ay upward minus 20 downward. Then plus by also upward, keep equal 0. Then ay is also 10 keep. And positive, that means upward. Okay, that is step number 1. Determine all the reaction. All the reaction is your step number 1 to draw normal force diagram, shear force diagram, bending moment diagram. So we just completed step number 1. Then we'll go to step number 2. Oh, I didn't tell you. Did you write it down? I'm not sure. I didn't check with you. Sorry. If you did not write it down, leave that space blank. You can fill it up later. I'm taking the video. Okay. So step number 2, show it in the beam. So we found it 10 keep. There is no load here. 20 keep here and 10 keep here. That is the reaction. This x, you do not need to show it. 0, why to show it? Okay. Then step number step number 1 is done. This is step number 1. Step number 2, if you want to draw normal force, and unfortunately there is no normal force here. You can see here there is no force this way, so there is no normal force. If there is normal force, you have to judge whether it is compressive or tensile. Okay, as there is no normal force here, there is no discussion. I will discuss it in another example. For this problem, there is no normal force. In fact, most of the cases in beam, there is no normal force, because in civil engineering, most of the load is vertical. And if there is no wind load and earthquake load is lateral. In that case, we get some normal force. Otherwise, if there is no earthquake or no wind, there is no normal force. Most cases, yes. That is, a normal force is very rare, and in fact, in most of the exam, nobody asks to draw the normal force diagram. Nobody asks it because it is not so common. Shear force and moment, very common, very important. In fact, the design of most civil engineering structure is just shear force and moment. So shear force moment, very, very important. 90% of your life, civil engineering life, is shear force moment. Okay, so step number 2, to draw shear force, what to do? Follow the loads. Okay, I'm writing here this very small sentence but very important. Follow loads. I am not adding the article. The follow loads. Now, what does it mean? It means whatever your load, follow it. Okay, so we will draw shear force diagram. That is my beam. So this way is my distance, say feet. That way is your distance. Follow the loads. At the beginning, you are at the beginning here. At the beginning, what is your load? 10 kip. You all agree that at the beginning my load is 10 kip. Now this 10 kip, up or down? Obviously up. So at the beginning load is 10 kip and up. So I'll go up. How much? 10 kip. So we followed our load. So at the beginning my load is 10 kip up. We went up. Then up to here or here, what is your load? Nothing. If, in fact, up to this portion you have nothing. Nothing means what? Nothing means do nothing. Follow loads, follow loads. That means no load, do nothing. So whatever we got here, do nothing. Keep as it is. So when I'm going right, I'm not changing, I'm not changing, I'm not changing. After I came here, there is something 20. So what we will do? Okay, take a new color. 20 keep. Now what 20 keep is telling me? It is telling me 20 keep down. Okay, so my value here was 10. You will agree with me because we got this 10 from here. Now we will go 20 keep down. So 10 down here, another 10 down here. So I will come to minus 10. Hopefully you know where I got minus 10. Minus 10 is I had 10 keep minus 20 keep equals minus 10 keep. That is this minus 10. So after this, what to do? Here, there is no load. No load means do nothing. Just continue what you had. So I'm going continue, nothing. After coming here, I found another 10. What it is telling me? Go up by 10. So go up by 10. I came up. I came here to 0. So that is the way to draw shear force diagram. And I believe you found it very easy if you know the reaction. And reaction, this is why we did reaction so many times in statics, many times. Statics chapter 3, 4, 5, 6, 8. These chapters are all about reaction. This is why we learned a lot reaction. Even now we are practicing it again. So hopefully you learned how to find shear force diagram, and it already told you why we need to go up, why we need to go down, because my load told. Now sign convention: anything up is positive, anything down is negative. That means in this segment you have negative shear, in this segment you have positive shear. But I told you earlier also, shear force negative positive doesn't matter. In your beam or steel beam or reinforced concrete design, reinforced concrete beam, whatever it is, the direction of shear force doesn't matter. Is the matter is the maximum one. Okay, so now we will draw moment diagram. Now what is the step for moment diagram? If you can remember, I told you sum up V, just sum up your shear force, and that will tell you which way to go. Okay, so I will go this way. This is my feet. Oh, this vertical line, I just showed this line. I'm here. Sum of shear force diagram. So at the beginning, I have no moment here. Beginning, we have no moment. It is 0. Now, how do I know at the beginning no moment or it is 0? I know this way is that if you can remember, at the beginning, I had a pin support. And you know that pin support cannot take any moment. So there's no moment at the beginning. Same thing here. Here there was a roller support. Roller support means it cannot take moment. So there is no moment. So there is no moment here also. These two answer I know it up front. Okay, then sum up shear force. What does it mean? So at the beginning you found 0, then sum up. Where oh, I made a mistake. Is sum up not the shear force? Sum up area of shear force. Area of shear force. Area of shear force. Even last slide. Yes, last slide I did not, I can remember. I said sum of shear force. It's not sum of shear force. Then if I sum up shear force, it is like shear force. It should be sum up the area of the shear force diagram. Area. So we will take the area. Now you can see here, my this portion is uniform. This portion uniform. 10 keep and distance is 10 feet. If you can remember. Then what is the area here? 10 times 10, 100 keep feet. So 100 keep feet. So when I'll come here, my moment will be 100 keep feet. Now the question is how I will come here. I will come here this way or that way or this way. I have 3 way to go there. If I know my value here 0, value here 100, I know the value, but how I will go there? Straight line, a concave up or concave down. So I have 3 options. Now, many ways I can answer this question, but I think the easiest way is whatever the value in shear force, whatever the value in shear force, that is the slope in moment diagram. Whatever the value in shear force, that is the slope in shear force diagram. That is number one way. Number two way I can tell you is that when I'm taking this area, the area of this shear force diagram, how my area is increasing? My area is increasing linearly. How? So here my top value is 10. If I go this way x, so at the beginning my area is 10x, x is 0, so 0. Then my area is 10 1, 10 2. In this way 10 10 is 100. So you can apply this common sense also, that my area is increasing linearly, proportionally. So my value will be straight line. So I will go straight line, not curve. Why? My area here is increasing proportionally or linearly, whatever you say. If I see this value, whatever the value here, that is the slope here. How? My value here is constant, positive. Again, you will agree with me, the value in shear force here is constant, 10 keep and positive. So my slope here will be positive, constant. That means straight line. So okay, what does positive slope means? If I draw the axis this way, it is positive. This way, if it goes down, if it is negative. If it is a straight line, 0. That is the slope. Positive means if I go right, I will rise, positive. Negative means if I go right, I will fall. So run, if I do some run, it will fall or rise. If it rise, then positive. If it falls, then negative. So my line here will be straight line. So this two way I can explain easily, that whatever the value here, that is the slope here. So we came here. After that, what is telling? Telling that the shear force is telling, then negative. You can see here this portion negative and minus 10. So value here is minus 10. That means my slope here will be negative. And this value here is negative, constant. So slope here will be negative, constant. So straight line. And then finally it will be 0 because we know this value. Now check. My moment here was 100. Okay, write down 100 minus this area, minus this area. So what is this area? 100 minus 100 times 10 equals 0. So if you sum up the area, or you know that there is a 0 here. So in this way we will come back to here. So that is my moment diagram. So hopefully I understood the question that somebody asked me, why moment diagram is going up? Because up means positive. Up means positive, and my shear force is telling me whether it is up or down. Whether it is straight line or curved line or horizontal line, the shear force diagram will tell. So now you can see that in the whole beam, you know where is the maximum shear force, maximum moment. Even if the question says what is the normal internal reaction at C here, simple. Come here, find this value, and we take a color. So find this value and this value. But yes, so that is one way to find internal reaction, or you can draw the entire diagram, and that is not so easy, sorry, not so difficult, it's easy. Okay, so this example I finished it. I will go to example number 2. Hopefully you understood this. Before going to example number 2, some clue is that um, where shear force changes sign, you can see here at this point shear force is 0. When shear force is 0, was change sign from positive to negative? or negative to positive. When shear force changes sign, positive to negative or negative to positive. Now, when shear force changes sign, positive to negative or negative to positive, it must cross the zero. It is common. If I want to go negative to positive or positive to negative, there is a point where its value is zero. If there is a point somewhere in your beam, at that point your moment is maximum. So this statement is very important statement. So where shear force is zero, there is a very good chance moment is maximum at that point. Now you can see my shear force is zero here also, zero here also, but it is not maximum here. It's not that everywhere it will be maximum, any of these 3 points where shear force is zero. But if you know that where the sign is changing, that is the critical point. Where shear force changes the sign, moment is maximum at that point. Now somebody may ask, if there are 2-3 points where shear force is changing the sign, yes, it is possible. If your beam is so long, continuous, there will be so many points, or there can be more than 1 points where the shear force changes sign. Yes, then you have to check all the points. Any of these 2 points, shear force is maximum. So that is something very important statement to remember. Another remember, if it is pin support or roller support, moment is zero. We know it from statics chapter 1. Support type, pin support or roller support cannot take any moment. So that is number 2. Another statement is free end. That means there is a beam here, say support here. This is free end. If it is free end, no moment. Now, do you need to memorize? No. When you will draw it, you will automatically see it. But something to verify your answer, cross check, that is some statement to memorize. Or when you will do many, you will automatically memorize it. Okay, so we'll go to example number 2. I am deleting this slide. Okay, another statement I just okay, let me stop the video to make it small. Cursor, come here.